So Apple just dropped what is basically a bombshell on the AI world. It's a new model they're calling Fast VLM. Today, we're going to break down exactly how this thing works, why it's such a massive leap forward, and, maybe most importantly, what it means for the devices you use, every single day.
All right, so let's just dive right in. I want to start with a question that kind of gets to the very heart of this whole thing, a huge challenge in AI. Just think about it. What if AI could see the world as fast as you do? I mean, for an AI to be a truly useful assistant, it has to perceive and react to what's happening visually in real time, right? Without that frustrating lag.
Okay, so to really get why what Apple did here is so significant, we've got to first understand the fundamental problem. This is something researchers have been wrestling with for years, and it all boils down to a really, really difficult choice.
So, we're talking about something called a vision language model, or VLM for short. The whole idea here is that these are the AI systems that let you, say, show it a chart, or a screenshot from your phone, or even a whole document, and then have a real conversation with it about what it's seeing. It's basically the magic that lets an AI see the world.
But here's the catch, the impossible trade-off that everyone has faced. If you want the AI to see all the tiny, important details, like the text on a sign or the numbers in a chart, you have to give it a high-resolution image. The problem? That creates a ton of data, and the whole system just grinds to a halt. It gets super slow. So the alternative is to use a low-res image. It's fast, sure, but then the AI is basically blind to all those crucial details. You had to pick one, detail or speed. You couldn't have both.
And that wait time, that pause, right, before the AI even starts typing its response, that is the enemy. In the biz, it's called TFT, or time to first token. And shrinking that lag, getting that first word out instantly without losing all the detail, well, that's been the holy grail for a long, long time.
So how have people tried to fix this? To really appreciate why Apple's new solution is so different, we need to look back at how the rest of the industry has tried, and honestly, mostly struggled, to solve this exact problem. And believe me, there have been some really clever attempts.
This whole journey has really just been an evolution of clever but flawed workarounds. You can kind of see the history right here. You had these early models using something complex called cross-attention to sort of weave the image and text together. Then came autoregressive models that tried to just process everything at once. And surprise, when those were way too slow, engineers came up with hacks like token pruning, which basically just means cutting down on the visual data to speed things up.
And this really lays out that whole history of workarounds, right? Every single one of these was a smart idea, but they all had a critical flaw. Cross-attention was powerful, no doubt. It let the AI really analyze an image deeply, but it was just painfully slow. And then you have those hacks like token pruning. Think of it like speed reading by just skipping a bunch of words. Yeah, you get through the page faster, but you're definitely going to miss some important details. Even the newer approaches were still stuck on that same core trade-off. They were all just band-aids, Patches on the problem, not a real fix.
And this is where Apple's team comes into the picture. They basically looked at everything that came before, all the successes, all the failures, and they decided to build something fundamentally smarter, right from the ground up.
What they created is a new engine called Fast ViT HD, and that HD is super important. It stands for hybrid design. That's the whole key right there. It's a model that's specifically designed to get the best of both worlds, combining two totally different approaches into one hyper-efficient system.
So here's how it works, and it's pretty brilliant. First, you've got these fast, super efficient things called convolutional layers. Think of them like a sprinter. They just blaze through the image, quickly grabbing all the local details. Then the heavy hitters, the transformer layers, take over. They're like the strategist, analyzing the big picture and figuring out how all those little details connect. But here's the real secret sauce, the key innovation. They added one extra downsampling stage. And what that does is it results in 4 times fewer visual tokens for the AI to process. Just way less work. And the result? Well, it's exactly what researchers have been chasing for years. The system could finally see high-resolution images, capturing every critical detail, but without that crippling, frustrating slowdown. They didn't just manage the trade-off, they broke it.
Okay, so the theory sounds great, right? But the crucial question is, how does this thing actually perform in the real world? And let me tell you, the numbers are, well, they're staggering.
Get this. When it's running at its highest image resolution, Apple's Fast VLM is a mind-bending 85 times faster in that critical time to first token metric. 85! That's not just a small improvement, that's a full-on generational leap.
And what's even crazier is that it gets this incredible speed with a vision encoder.
That's the part that actually processes the image. That is 3.4 times smaller. It's just unbelievably efficient.
It's literally doing more with dramatically less work. To get the job done, it generates up to 5 times fewer of those visual tokens compared to other top models out there.
Let's put this into perspective with a head-to-head comparison. When you put it up against Cambrian 1, which is another really strong model, Apple's Fast VLM is nearly 8 times faster. Just look at that gap. It's not even close.
But here's the thing, it's not just about being fast, it's also smarter. On a really tough benchmark called Text VQA, which basically tests how well an AI can read and understand text inside of an image, it's over 8% better than the competition. And across a whole bunch of other major tests, it either matches or flat out beats the current leaders. But you know, maybe the most exciting part of this entire story isn't just the raw performance numbers. It's where they got these numbers. See, Apple didn't run these tests on some giant multi-million-dollar server farm hidden away in a data center. Nope, they ran them on a regular MacBook Pro using the Apple Neural Engine that's built right into the chip.
And this shows you just how practical that is. To do something like understand a complex document, Fast VLM needs way fewer tokens than other models. I mean, we're talking less than 1/10 of the computational work. That is the kind of insane efficiency you need to run AI on your actual device.
And that right there, that proves what their goal is. This is not some research toy or a theoretical paper. This is tech that was built from day one for your pocket. It's designed to run locally and efficiently on the phones, tablets, and computers you already have.
So, the big takeaway here is this. By brilliantly combining the best of different AI approaches, Apple didn't just put a Band-Aid on the AI vision problem. They solved it at its root. They've basically set a whole new standard for how fast, how efficient, and how powerful AI vision can be, right there on your device.
And that leaves us with one final and really exciting thought. Just imagine it. Forget all the lag, forget the limitations of the past. What happens next? What new apps, what new kinds of assistants, what incredible new possibilities open up when the AI in your hand can finally see and react to the world just as fast as you can?